Well, hello there everyone, this is KP the Math G here, and well, we are looking at 2026, a 2026 question. It's a free response question, number 5, and in this case, this is part D. Part D. So what we're going to do is we're going to find the average velocity, and I kind of abbreviated that just a little bit. Says find the average velocity over the car over the time interval where t is between 6 to 12 seconds. Show the work that leads to your answer. Alright, so I want to show you something. If you're trying to figure out distance, which was part C, using this function, we could find distance if we just did this. I'm going to use green. Let's see if that green shows up good. Now, we are saying, first of all, where t is between 6 and 12. Alright, so we do know that we need to have up here a 6 and a 12. 6 and 12. And we need to see where that corresponds to. That corresponds to this equation. Now, when you have, some people call this a piecewise function, and rightly so, because it is divided into 3 pieces, but I refer to say this is a 3-part equation here, or v at t, for different times. Okay? But in this case, if we're looking at this time, we're choosing this. This is at rest during this period of time, from 4 to 6 seconds. And then for t being from 6 to 12, we're using this one. So we are going to use 10 cosine pi over 3t. Alright, that is a t right there. Minus 10 dt. If we were looking at how far, or distance, how far did this car travel when t is between 6 and 12 on that interval, this would be all we're doing. The problem is, this is distance right here. But when we talk about average velocity, and every time you see that, you cannot just leave it like this. You just simply do 1 over the higher number minus the lower number. Okay, like that. Well, 12 minus 6 is 6. So 1/6. You just simply subtract. 12 minus 6 is 6. That puts us back to velocity, or in this case, average velocity. Okay? So whereas without this, you're dealing with distance like feet, now you're getting back to feet per second when you take the average like this. It puts you back to velocity all of a sudden. And you just have to remember, average velocity is going to look like this at all times. Had this been, say, from 5 to 10, 10 minus 5 is 5, so 1 over 5. Simple as that. So if we got it set up properly, I do like to have, I've got a cat in here, so if you hear a meow going on, that's what you're hearing. I would like to kind of fix this up a little bit because I see a 10 and a 10. So I do have a 1/6 from 6 to 12, and I'm going to take out a 10. Now I'm left with cosine of pi over 3 t. Now 10 times 1 is 10 dt. That is what I want there, and you could actually put the 10 on the outside and multiply it by the 1/6 if you want to. 10 times 1/6 is 10 over 6. 10 over 6. So we can do that. Erase the 10 and make that 10 over 6. We can do that. Put it on the outside there. You don't have to fool with it until later. Until later, right? Well, let's turn this over. We've got a long problem here. Alright, I'm going to try to memorize that. 10 over 6. Oh, bear with me. I don't have enough room to flip this over, so let's move it forward. Cat's going crazy looking at me doing this. Okay, let's do it. Let's move it back. Alright. In this little room, it's not a lot of room here, I'll tell you. Okay, right there. I think that's going to work. So we are going back to 10 over 6. We're going from 6 to 12. We're saying now cosine, what is it, pi over 3? I don't know, what is it? Pi over 3t. Now minus 1. Remember we had a 10 here, we took it out. 10 times cosine, cosine of this is cosine of this. And then 10 times 1 is 10. There's a minus sign in between. You do not want to get in here and make make an error on sign. Okay, 10 over 6 is 5 over 3, so we can do that if you want to. You know, some people like, when is he going to change? When is he going to reduce it to the lowest term? Okay, I got it. Okay. Now, let's just put the 5 over 3 because we got plenty of room. I need plenty of room. 5 over 3 then. Alright, there we go. Now, see if I can get a different color. And my color is starting to fade on some of this, so I got some more of those, some new ones just in case. Now, anytime you are integrating, especially something like this, and you'll learn over time what to do. Okay? You want to let u or w or something other than t be equal to, u's just been something that I've used, well, for a long time. You don't want it to be minus 1, you don't want it to be cosine of this, just what's inside here, okay? Let it be pi over 3t. And what you do is, now I'm going to show you something. I didn't learn this. I took calculus in college, and I didn't learn this until I started teaching it. And some teachers showed me this, and I liked that. But you got to really know that that's when you can do that, what I'm about to show you. Alright, so what I'm saying is 5 over 3, we're going to change the bottom and the top. You can leave it like this. You can. You can integrate it with this in here. You can. Well, we'll show you something. And maybe, just maybe, if you follow me, you're going to see that your life is going to be made a whole lot easier. Okay? Now, I've got a cat named JJ right here. Hello, J. Say hello to everybody, JJ. Alright, go. Big old thing. Boy, he's spoiled rotten. Alright, let's get back to it. U is this. Let's take the 12. I'm going to change that. So U is equal to 1/3 times 12. Which to me, that's 12 over 1. So that's 12 pi over 3. 12 pi over 3, which is really 4 pi. So in place of this, I'm putting 4 pi. I am not using 12 anymore. Well, I substituted here. Let's do the same thing for 6. Alright, and we'll plug the 6 in. Okay, just like that, in place of t. Alright. Now that's 6 pi over 3, which is 2 pi. I'm going to put it right here. Now, let u be equal to, keep that in mind. Alright. Well, alright, we did that. Now, you still want to do du, then du. Du, the derivative of the left side is just du. The derivative of the right side is pi over 3, but you got a t here, so put a dt right there. Always remember to do that. In dealing with definite integrals, you want to isolate dt, so we're going to do just that. Oh, this thing doesn't want to write. Get a different color. Well, let's get another shade of blue. Hopefully it works. Yeah, it's looking good. Multiplying by the reciprocal, right? Just multiply by the reciprocal. You see all this divides out. So you're left with dt is equal to 3 over pi du. Now, here's what I do here. I should have left a little room. Let's move the 5/3 over just a little bit, because I should have known I'm going to multiply by something. Put that something on the outside right here. Okay. Now, be very careful here. You've let u be equal to pi over 3t, so make it that way now. Since you changed this, you cannot put this back pi over 3t. If you want to keep 6 over 12, you keep that. But if you want to keep these, now you have got to put cosine u. You know what? I like integrating cosine u. Now, one time I worked this problem, and guess what I left out? The -1. Oh! We don't want to do that. Makes a difference. Alright, now I know you're ready for me to cancel out these 3, so I'll do that. So 5 over pi rather. 4 pi, 2 pi to 4 pi now. Alright, now, well, just put 5 over pi right here, because I need all the space I can get. 5 over pi. We're down to 5 over pi right here. Okay. If you followed me down to this and you're understanding it, good deal. And I might have to come up with some more of these videos to do some more problems like this, but yeah. Now I can integrate. Only thing is, with integrating cosine u, The derivative of cosine is negative sine, so the antiderivative of cosine is positive sine. So I do remember that. So 5 over pi. Now sine, remember it's in u now, in terms of u. Now remember, when you take the antiderivative of a constant, it's that constant times u, so just 1u. Woo, I left that off last time. And we're going from 2 pi to 4 pi. Alright. Woo, that's a lot of stuff, isn't it? Guys and girls, men and women, ladies and gentlemen. But when you do this, don't do du right away. Just start plugging those 6 and 12s in there. 12 first, get your top one. You can do 6 first as long as you put it at the bottom. Do that. Now, let's evaluate now. That's equal to 5 over pi. We're getting close to the end now. Sine of 4 pi minus 4 pi. Got to watch your signs doing this. I like to just kind of block that off. Alright. Now minus sine. Woo! Needs room. Let's put it. Ooh, I don't know where to put it. Let's see if I can put it right here. Minus sine. Sine of 2 pi minus 2 pi. Woo! Alright, like that. Sine of 2 pi minus 2 pi. Or I just don't have any more board. Alright. Well, let's do a little evaluating now. All this is together now. Oh, you gotta remember that. All this is together. Alright, so 5 over pi. Alright, all of this. Now let's think of sine 4 pi. Let's get an answer for that. I know what sine looks like. Like that. And I know this is pi. I know this is 2 pi. Well, I already know that 2 pi is 0. I already know that's 0. Well, 4 pi is going to be the same because I'm going to make another wave. This is 3 pi. And that's 0. And this is 4 pi. And that's 0. So just extend it on out. So this is 0. Sine of 0. Well, no. Sine of 4 pi is 0. Get that. 0 minus 4 pi. Got that. Now it's starting to look a little simpler. Okay, let me erase this. And boy, it does have to know those graphs, what those graphs look like. And don't forget that minus sign. That's huge. Minus sign. Sine of 2 pi is also 0. Minus 2 pi. Woo! There we go. So that's equal to 5 over pi. Alright, times. 0 minus 4 pi is negative 4 pi. 0 minus 2 pi. So minus sign here. Don't forget that. Wow, don't forget that. Negative 2 pi. Alright. So minus a negative is a plus. So for lack of that, I'm just going to go ahead and put that plus sign. So negative 4 pi plus 2 pi is negative 2 pi. 5 over pi times negative 2 pi. Put that over 1 if you want to. And those pi's cancel out. And this is negative 10. Now you got to remember, you started off with feet per second. It is average velocity. Do not write down feet here. You did not find distance. You found average velocity, okay, per second. there it is. Now remember, velocity can be negative. Okay? Alright? Negative velocity. Like if an object's going up, velocity's positive, 0, negative. Alright? Sometimes we refer to on the number line. If you're going to the left, negative velocity. Going to the right, positive velocity. Sometimes we look at it that way. In this case, you can have a negative feet per second. If you're talking about speed, you put that in absolute value bars, and that'd be 10 feet per second if that's speed. But we're not talking about speed, we're talking about average velocity. So there it is, negative 10 feet per second. I think the biggest thing, you're going to have to practice this so that you'll understand what you're doing. If this had been something like 2t plus 1, you would have plugged 12 and 6 into 2t plus 1. Or 2t minus 1, or whatever. Whatever this, I guess some people call it the argument, whatever this argument is, you're just going to plug the 12 and the 6, and then replace them. Okay? Sometimes this number is going to wind up being smaller than this one. And you can still do it, still works. Alright, but what the idea is I'm not dealing with pi over 3t, I still have u. If I had more time, which I may go ahead and do this one again, and just integrate it without changing the 6 and the 12. And if that will help you understand it better, so be it. I want you to understand it, okay? I did not have to do this, but I just kind of like cosine u. Now again, another thing you got to remember is, what's the antiderivative of cosine is sine. I always like to think that anything that begins with a c, the derivative is negative, but in this case with cosine, the antiderivative is positive. Okay, so sine u, and remember that when you do this, this is just u here, and that should not be a t here, that should be a u. So everything's in terms of u. There we go. There it is. And now that's what I've got here, negative 10 feet per second. Alright. Wow, that's amazing that those pi's cancel out and we just got negative 10. That's something, isn't it? Should have. Well, maybe. Okay. Anyway. Turns out good, doesn't it? Well, that's how it works. Lengthy problem. I did a few things like changing this. Okay? And then, of course, you cannot keep this here. If you change this, you've got to change that to u, which you let u be. Okay? If you leave this the same, you got to leave this the same. There's no u here. If you change these two, you leave that as u. Got it? Alright. Anyway, this is KP the Math G getting ready to sign off. Really nice problem here. Okay? That makes this, I think I'm going to have 186 videos after this one. I want to get up to 200 and then start just doing other things, maybe some algebra stuff, maybe some college algebra stuff, I don't know, but I'm enjoying right now doing just the AP calculus. I really enjoy this. KP the Math G is getting ready to sign off. Hey, listen, if you want to subscribe, please do so. I've got a really nice comment who's someone who said, I'm going to show this to all my friends. Well, friends, student, subscribe if you want to. If you don't want to, that's okay. I like those who subscribe. I like to see those subscribes grow, but it's not about me, it's about you. Make a comment if you'd like to. Kind of like comments as well. And then, you know, if you want to hit that like button, man, that just puts a smile all over my face. Anyway, doesn't matter. It's all about you, and really none of this is about me. And maybe one day I will get a job doing online tutoring. I hope I will. That is my goal. I hope I get to do that. And I will do that as long as I possibly can, especially if it involves AP calculus, right? Alright. KP the Math G signing off. Ladies and gentlemen, have a great, great day.